First is we have hot rolling. In hot rolling, the metal is rolled above its recrystallization temperature. This makes the metal soft and easy to deform. It helps also in reducing thickness, removing internal defects, and improving ductility, the ability to stretch without breaking. However, the surface finish is usually rougher than cold rolling. For example, is the railway tracks, structural beams, and plates. Second type of rolling is cold rolling. In cold rolling, the metal is rolled below its recrystallization temperature. It is often in a room temperature. This causes strain hardening, which increases strength and hardness. It also gives a better surface finish and higher dimensional accuracy than hot rolling. So, an example for this are thin sheets for cars, household appliances, and also packaging. So, in simpler terms and in short terms, hot rolling are easier for shaping, removes defects, and also improves ductility, but rough finish. While the cold rollings are harder metal, stronger, smoother surface, and more precise. Third is we have shape rolling. It uses grooved rules to form specific shapes. Examples are L-beams channels. So it produces strong and uniform structural parts. Lastly, we have the thread rolling. So it is forms screw threads by rolling, not cutting. Makes threads more stronger, smoother, and faster to produce. So, in simple terms, shape rolling makes structural shapes, while the thread rolling makes screw threads.
Good day everyone, I am Joanne E. Cortez, one of the representative from Group 3, and I am here to discuss about my assigned topic, which is all about extrusion and drawing processes. So first, let us discuss what is extrusion. So extrusion is a process where a pellet or block of metal or plastic is forced to flow through a die opening to produce a product of fixed cross-sectional shape. So as you can see, I have provided there a diagram which shows its key components or the exact process of the extrusion also. So as you can see, we have there a pellet, die, and ram and extrusion, but the components there is only the pellet, die, and the press, which is the machine. So what is the pellet? So pellet is the raw material you start with. So it's a black or thick rod of metal or plastic that you want to reshape. Then the die, this is a thick, durable plate with an opening cut into it. So the shape of this opening is exactly the final cross-section you want to create. Then the press, it is a powerful mechanical or hydraulic press, pushes on the pellet with high pressure, forcing the material to flow through the die opening. So this is how it works. So the pellet is often heated to soften it and make it more pliable. For metals, this is done at high temperatures, and for plastics, the pellets are melted. Then in pressing, or with the use of the press or the machine, the heated pellet is loaded into a container and ram pushes against it. Then in shaping, the immense force from the press squeezes the softened material, making it flow out through the shaped opening in the die. Then, in its final output, as the material exists the die, it takes on the exact cross-sectional shape of the die opening, so creating a long continuous length of material called an extrudate. Then in finishing, the long extruded piece is called and then cut to the desired length. So in extrusion process, it's bit like squeezing toothpaste from a tube or frosting from a peeping bag. So in other hand, the shape of the product is determined by the shape of the die's opening. So this is all about the extrusion process, how it works, and its key components. And now let's move forward to the two types of extrusion process, which is the hot and cold extrusion. So first, hot extrusion. So in hot extrusion, material is heated to reduce resistance, or it is used for metals like aluminum and copper. Then next is cold extrusion. So cold extrusion is done at room temperature, resulting in better strength and surface finish. So here's the differences between the two types, which is in hot and cold extrusion. So hot extrusion performed at high temperatures above the material's recrystallization point to soften it, while on the other hand, cold extrusion performed at or near room temperature only. So next, let us move forward to the extrusion applications. So under extrusion, there are 4 applications. First, we have the aluminum. Second is the plastic products, which includes PVC pipes, rods, and sheets. Then third is the pipes and tubes, and the last one is the aluminum window frames. Then now, let us move forward to drawing processes. So what is drawing processes? So drawing is a deformation process where the material is pulled through a die to reduce its diameter and increase length. So as you can see, I have provided a diagram. So in the diagram, there is a workpiece which is larger than the output. So drawing is deformation. So from its original size, which is larger, then iya siyang i-reduce ang diameter and i-increase niya ang length. So there is changes. Now next, let us move forward to the types of drawing. So there are 3 types of drawing. First is the wire drawing, second is the tube drawing, and the last one is the deep drawing. So wire drawing reduces the diameter of a wire. So it ma-apply ni siya sa wires, from the word wire drawing. The next is the tube drawing. So tube drawing reduces diameter and wall thickness of the tube. Then next is the deep drawing. So it produces hollow shapes like cans in container from shape to metal. Then the last part is the drawing application. So under the drawing applications, it also has four applications. So first we have the electrical wires and cables. Next is the bicycle spokes. Then third is the needle pin and spring. Then last is the beverage cans in the automotive body or deep drawing. So that is all about my presentation. I hope you learn from my presentation. Thank you so much for listening.
Good day everyone, I am Herschel V. Macabingo, and for the continuation of our discussion, I'll be talking about the applications of forming and shaping processes in construction. Now, these processes are super important because they actually take raw materials and turn it into something now we can use for building. And if you think about it, almost every material we can see in construction has gone through some kind of forming or shaping to make it fit the design and purpose of a project. So let's go through some examples. Let's start with concrete forming. Concrete is usually poured into molds so we can form slabs, beams, columns, or even walls. Aside from that, it can also be shaped into blocks, tiles, pipes, and even decorative elements. So without forming, concrete will just stay as plain mixture and not be as useful. Next, let's talk about steel or metal forming. Steel is very important because it gives strength to sa mga buildings, and also by forming processes, it can be rolled into some